Here's an example for you to try. Count the paths from the root of a tree where the total sum of the labels along the path are some total number that you pass in. So the input to this function is a tree t and some total number, and the goal is to return the number of paths from the root to any node in tree t for which the labels along the path sum to total. Any node in tree t means that this doesn't have to go all the way to a leaf. It still counts as a path if it starts from the top and meanders for a while without getting all the way to a leaf of a tree. So here's an example tree. For a problem like this, it's always a good idea to look at an example and draw that example out as a tree. So here we have 3 branches. One of the branch has 2 branches. One of its branches has a branch. And we're looking for path sums. So for example, how do we sum to 7? Well, here's one way. 3 plus 1 plus 2 plus 1. And there's another way to sum to 7 right next to it. 3 plus 1 plus 3. And that's 2 different paths that total 7. How about 4? How do you get to 4? Well, here are 2 different ways, and notice that neither of them go all the way to a leaf, but we still get an answer of 2. And what about paths that total 3? Well, it turns out that here's one, a really short path that goes from the root to the node, which is at the root. That's any node in the tree. And along this path, there's only one node label, which is the number 3, which is the total we're looking for. And there's another path. 3 plus 1 minus 1 gives us 3. What's interesting about this example is that we see we can detect a path with the total sometimes just by looking at the label of the root. And the other interesting thing is, once we've found a path, we might have to continue looking within the tree where we found a path to see if there are any more paths. For this reason, we won't have a structure that just says, if I find a path, return 1, otherwise, count the paths below, because I might find a path and need to look for more paths that also total whatever the total is. That's the kind of thought process that I think you have to go through in order to solve a problem like this. And once you understand that structure, you can start thinking about a strategy for solving it and how to write that in code. So I'll stop there. I would encourage you to pause the video and try to solve it yourself. And then I'll go through the solution in 3, 2, 1. Here we go. The return statement here says I've found some number of paths, and then I need to add up some recursive sum about the other paths that I've found. How might we come up with a solution to this problem using recursion that has that structure? Well, here's one way to do it. We'll consider 2 cases. Paths that end at the root t that I've seen, and paths that end somewhere below it in one of the branches. How many paths could there be that end at the root of t? Well, there could be 1, or there could be 0. 1 if including this label at the root reaches the total, and 0 if it doesn't. In the case that we haven't found a path that ends at this node, there might still be paths that continue on below this node. So one way to structure that logic is to check and see if we've found a path that ends at the root, and the only way that we'll reach the total is if the label of the root is in fact the total, at which point we've found one path. Our goal is to count paths. Otherwise, I'm going to refer to found down here, but I haven't assigned it to anything if I haven't executed this line, so I do need to assign it to something. Otherwise, I'll set it to 0. So either I found a path that ended at the root label, or I didn't, but I also need to count all the paths that end in one of the nodes of the branches. My goal is to count how many such paths there are in each branch, b, for all the branches in T. I'll do that with a recursive call to count paths. And once I find out how many paths there are in each branch, I want to sum them up. All right, we're finally to the heart of the problem. How do we make the recursive call? We're going to make a recursive call on each branch. That's a typical structure. We're also going to account for the fact that we're considering paths through the current node, and therefore, to get the total, we're going to have to consider the label at the current node. If I was originally looking for 7, I would have to subtract out this 3 and look for a path down here that adds up to 4. And here's the logic to do it. Take the total, subtract the current label's value, and that's the total that remains in order to reach a full path sum of total by considering a path through the current node at the root and then followed by some path through one of the branches.